Hello, welcome to this class. Today we have mathematics and we are going to discuss Pythagoras Theorem. Before we go into the topic, let me welcome you to Uncle Maths Online Academy. For choosing to join us, you have chosen to become the best in your class because at Uncle Maths Online Academy, our mission is to make sure that you become the best in your class. If you are not yet the best in your class, we will do everything to make you the best in your class. And if you're already the best in your class, we will do everything to keep you being the best in your class. At Uncle Maths Online Academy, we give our students the best. We teach you and we give you assignments, quizzes, and homeworks to test your performance. So, somebody who has chosen to join us, you have decided to work because you'll be having a lot of assignments. You should get prepared for it as our students. Now today we are going to talk about Pythagoras Theorem. This is talking about triangle, a special type of triangle. We believe that you already know what triangle means. That a triangle is any shape that has three sides. And we also believe that you know the types of triangles that we have: the equilateral triangle, the isosceles triangle, the scalene triangle, and the right-angled triangle. For today, our focus is going to be on right-angled triangle. A right-angled triangle is a type of triangle that has one of its angles as 90 degrees. One of the angles in a right-angled triangle is 90 degrees. Now there is a man called Pythagoras. This man discovered that the size of a right-angled triangle, that there is a relationship that exists between the sides. And that relationship is what we call Pythagoras Theorem. In a right-angled triangle, there is a side called hypotenuse and other sides are called adjacents. We've said that in a right-angled triangle, one of the angles is 90 degrees. Now the side that is facing the angle 90 degrees is what we call hypotenuse. As you can see in this picture, in this triangle, this is the angle 90 degrees. The side that is facing it is called hypotenuse. That is the longest side of the right-angled triangle. Now, other sides of the triangle are called adjacents. This is an adjacent. This is an adjacent. So, a right-angled triangle has one hypotenuse and two adjacent sides. One hypotenuse and two adjacent sides. This is an adjacent, this is an adjacent, and this is a hypotenuse. Now the theorem, the Pythagoras theorem, tells us that this longest side, which is the hypotenuse, that the square of it is equal to the square of the sum of the other sides of the triangle. If we represent the hypotenuse with h, and this side, let me call it A, the first side of the first adjacent, and maybe the second adjacent, let's call it B. Now this man is saying that h squared is equal to a squared plus b squared plus b squared. That is, the square of the hypotenuse is equal to the square of the first adjacent plus the square of the second adjacent. This is what we call the Pythagoras theorem. Hypotenuse squared is equal to first adjacent squared plus second adjacent squared. Or if we represent the hypotenuse with h and then the other sides as a and b, then we can now say that h squared is equal to a squared plus b squared. So that is the relationship between the sides of a right-angled triangle, that the hypotenuse squared is equal to the first adjacent squared plus the second adjacent squared. Now, with this, we can solve any problems that we have about right-angled triangle. So let's solve some examples. Example 1. Example 1. Now, if we have this triangle, and we have here as 2, we have here as 2 and we have here as 4. Then we have this sign. Now, anytime you see this sign in a triangle, it means that the angle is 90 degrees. It has pointed face. It is called a perpendicular sign. When two points join and we use this sharp arrow to represent the angle there, it means that the angle there is 90 degrees. Now that means that the angle here is 90 degrees. There's a difference between this and this. If we represent the angle with this, like this, if we present it like this, it is not sharp, then it is not 90 degrees. But when we draw an angle and then the sign is very sharp like this, it is called a perpendicular sign, which means that the angle there is 90 degrees. But if it is not sharp, you see that this one is sharp, but this one is not sharp. It is not pointed. So this one is not 90 degrees. This one can be anything. This one can be 20, can be 30, can be 40, can be 50, can be 60, 70, 80, 100, but it cannot be 90. But this one that is sharp is always 90. Okay, so here we have a pointed one, which means that this angle is 90 degrees. Now for knowing that this angle is 90 degrees, we now know that this angle is right angled triangle. If we are given this triangle and maybe we are told that this side is H, and we are asked to look for the value of H, and we should find the size of this H. How do we calculate it? We calculate it by first of all telling ourselves that this angle is a right angled triangle. A right angled triangle. And for being a right angled triangle, H squared, H or the hypotenuse is the side that is facing the angle 90 degrees. So this side is facing it. So that is the hypotenuse. So the hypotenuse squared is equal to the other side, sum of the other sides squared. That is the first side squared, then the second adjacent side squared, which is 4 squared plus 2 squared. And so we are going to have that H squared is equal to 4 squared is 16 plus 2 squared is 4. 4 squared means 4 times 4, and 2 squared means 2 times 2. 4 times 4 is 16 and 2 times 2 is 4. Now this means that H squared is equal to 16 plus 4 is 20. 16 plus 4 here is 20. Now that means that H, if you have a square at one side of an equation, this is an equation because of the equal sign. If you want to remove the square from this side, if you are taking it to this side, we make it a root, square root. If it is square here, this side it will become a square root. So the H remaining alone is going to be the 20 root of it, root 20. Root 20 is equal to 20 is there any perfect square inside 20? What is a perfect square? That is an assignment number 1 for you. Find the meaning of a perfect square. Now we have a perfect square. 1 is 4. 20 is 4 times 5. Now let me just help you. A perfect square is a number that its square root does not give a decimal point. When you find the square roots of a perfect square, you will not have anything like point this or point that. If you have the square root of 4, it is 2. But if you look for square root of 5, it will give you 2 point something. So 4 is a perfect square because the square root of it does not give us a decimal point. But 5 is not a perfect square because the square root of it will give us a decimal point. So that is the meaning of a perfect square. Now, anytime you are trying to look for the square root of something, check if there is a perfect square inside it. Then you bring it out, find the root of it and write it. Then the other ones that you cannot get their square roots, just write the square root along with it as the final answer. Now, what I mean by this is this. This root 4 times 5, which is 20, is the same thing as root 4 times root 5. This root covering 4 and 5 is the same thing as root 4 times root 5. Now, what this means is this. Since root 4 is 2, now the final answer is going to be h is now equal to root 4 is 2 times root 5. We cannot get 5 is not a perfect square. So if we try to get the square root of it, it will give us a decimal point. So we can just leave it like this as root 5. 2 times root 5 is equal to 2 root 5. If you have a whole number and you have a square root, if you times 2 of them, just bring the whole number and the square root together. Write the whole number first and then write the square root, the one with square roots, and that is the answer. So just remove the multiplication sign, bring 2 of them together, write the whole number, which is this one, first, and then bring the one with square roots close to it, and that becomes 2 root 5. So this is the answer. So our h is 2 root 5. If you have a calculator, we can look for the value of this, of root 5, and times it to give us the value in decimal points if it is needed. But if it is not needed, we can leave it this way. So this is the answer. Example 2. Example 2. Now sometimes they may give us the hypotenuse and ask us to find the size of the other sides of the right angle triangle. For instance, we can have something like this, then they will intentionally give us the hypotenuse. You see that this side is facing the right angle, the angle 90 here. This is pointed, so it is 90 degrees. So this is the side facing it, so this is the hypotenuse. Now they gave us this side as 90. In this example, the hypotenuse is 90. Now we have this side as 3, here 3, and we have here as a. Now assuming we are given this in an exam and we are asked to find the value of a, how do we calculate it? Now if you watch, in the first one we solved, we calculated the hypotenuse. We are given the adjacent and we are asked to look for the hypotenuse, which we calculated. Now this place now, they are trying to be small, trickish. Here we are given the hypotenuse and we are asked to find one of the adjacents. Now the same thing we did when we are given the two adjacents is what we still do here. We just remember our rule, the Pythagoras theorem. Once it is a right-angled triangle and we are looking for any of the sides, we use the Pythagoras theorem by stating that hypotenuse squared is equal to a squared plus b squared, where a and b are the two adjacents of the triangle. Now hypotenuse here is 9, so we say 9 squared is equal to, let's say that, okay, this is a squared, then plus the other side is 3, so we have 3 squared. So we are going to have that 9 squared is what? We are going to have that the 9 squared is going to be 81. 81 is 9 squared. It is equal to a squared plus 3 squared is 9. So 81 is equal to a squared plus 9. 9 squared is 81. A squared is the one we are looking for a, and the other side is 3, which is 3 squared. Now 9 squared is 81. A squared, the one we are looking for, and 3 squared, which is 9. Therefore, we have that 81, this 9 coming to the other side, it has positive side here. If it is coming to this side, it becomes negative. So it is coming to meet the 81 so that like terms will stand together. Like terms, this one and this one, they are numbers. They are numbers, figures. Why this one is an alphabet. So let the alphabet stand alone and let the numbers stand on their own. So bringing the 9 to stay with the 81, it has positive sign here. If it is coming to this side, once it crosses this equal sign, it becomes negative. So 81 minus 9 is equal to a squared. Now this means that 81 minus 9 is what? 81 minus 9 is 72. So we have 72 is equal to a squared. Now we clear this square here by taking it to this side. To take it to this side, it becomes what? Square root. If a square is crossing equal sign, it will turn to square root. So we have that 72, square root of 72 is equal to a. Please note that this thing is still equal to, we can still write it as a is equal to 72. So whether we have the a at the left hand side or at the right hand side, it is still the same thing. So here 72, we now check again whether there is a perfect square inside 72, and yes, there is, because 72 is equal to 18 times 4. So a is equal to 18 times 4. 4 is a perfect square. So we put it. How do we do this? First of all, if you have your calculator, start with 4. 4 is the first perfect square. Use it to divide the number. If there is any remainder, if there is any point, it means that 4 is not a perfect square inside that number. Then you use another perfect square, which is 9. After 4, another perfect square is 9. So divide that number again with 9. Divide by 9 and see whether there will be remainder. If there is remainder, it means that 9 is not a perfect square for that number. It's not a perfect square inside the number. Now, another perfect square is 16. Use 16 to divide the number and check if 16 is a perfect square inside the number. Now here, if we use 4 and divide 72, we will get 18 without any remainder, which means that 4 is a perfect square inside 72. So we write the two numbers, which is the 18 and the 4. Now the essence of it is so that we can now get the square root of 4 and then find the square root of 18. Now 18 itself is a now is equal to root 18 times by root 4. Now 18 itself, we check whether there is any perfect square inside 18. If we divide 18 by 9, we get 2. That means that we have 9 as a perfect square inside 18. So it means that this is equal to root 9 times 2, then times by root 4, because 9 times 2 is 18. Now what this means is now we can now separate all the square roots. So we have this is equal to root 9 times root 2 times root 4. Now what this is going to give us is this, that a is equal to root 9 is 3. Root 9 is 3. Now times by root 2 is not a perfect square. 2 is not a perfect square, so we write it as root 2. And root 4. 4 is a perfect square. Square root of 4 is 2 times by 2. Now the ones without square roots, we write them first and put the one with square roots in front of them. So we are going to have that a. So this is going to be a is equal to, we write 3, the ones without square roots, we write them first, then times by 2, then times by the one with square roots. That means that a is equal to 3 times 2, we times these 2, 3 times 2 is 6, 6 times root 2. Now I've said that if you have a whole number and a number with square roots, you just bring the two of them together, you write the whole number first, remove the multiplication sign, and write the one with square roots. So it becomes 6 root 2. So this is the answer. This is the answer, 6 root 2. That is the value of A. So in this triangle, A is 6 root 2. Now we solve another example. Example 3. Example 3. Now here, they may decide to draw the triangle in another form to confuse you. Now, no matter where the hypotenuse is facing, once the triangle has a perpendicular sign, it is a right angled triangle. Now, for instance, if they draw it like this, let me draw it again. If we have something like this, okay, now they put something with a sharp edge here, now which means that this place is 90 degrees. Now we have here, maybe here as 7 and here as here as 20, then here as B. Then they can ask us to find the value of B. Now you should not say that because it is not standing this way, that it is not a right angled triangle. No matter where this is facing, as long as we have this perpendicular sign or 90 degrees inside the triangle, it is a right angled triangle, no matter where or how the triangle looks. So what we are going to have now is that since we have confirmed that this is a right angled triangle, we use the same Pythagoras theorem, which is that h squared is equal to a squared plus b squared. Now where this side facing the perpendicular sign is the hypotenuse, which is the 20, that's the longest side. So we have that 20 squared is equal to the first adjacent is 7 squared plus the second adjacent is b squared. So we are going to have that 20 squared is what? We are going to have that 20 squared is 400. 400 is equal to 7 squared is 49. 49 plus b squared is b squared. 49 plus b squared. Now this is the same thing as we make this one becomes 400 minus 49 is equal to b squared. We just collect like terms, make the numbers to stand on their own and the alphabet too. So we collect like terms here. The numbers will stand on their own and the alphabet will stand on its own. So we have 400, 49 from this side coming to this side it has positive sign here. Coming to this side, it will take a negative sign, so it becomes 400 minus 49, and now the b is standing alone here. 400 minus 49, this will give us 351. So 351 is equal to b squared. 351 is equal to b squared. Now we check if there is any perfect square inside 351. 351 is actually 351 is 39 times 9. So we can also write it as b squared is equal to b squared is equal to 351, and which means that b is equal to root 351, and now b is equal to, if we divide with 4, it will give us a decimal point, but if we divide with 9, we are going to get 39. We are going to get 39 now, which means that this is equal to 39 times 9. So we have a perfect square inside it. Now it is not a must that it will have a perfect square inside it. We just check to know if there is any perfect square inside it. If there is any perfect square, we simplify further until we break the perfect square. But if there is no perfect square, we leave the answer like that. Or if we have our calculator, we can find the value of the roots and write it. But if you don't have a calculator, we just leave it that way. Now this becomes b is equal to root 39 times root 9, which is equal to root 39, root 39 times by root 9 is 3. Now we cannot write it this way. We have to write the whole number first before we write the one with square roots. So it becomes 3 root 39. So this is the answer, 3 root 39. You can also check to see if there is any perfect square inside 39, and you break it down again if there is. But if there is no perfect square again inside 39, you leave it like this. That is the answer. Now again, example 4. Example 4. Now they can also draw the triangle this way. We can have something like this. You just be watchful. What you'll be looking for is the sign for 90 degrees. Is either they write it 90 degrees, is either they put 90 degrees there, or they just put the sign for 90 degrees. So just watch inside the triangle and see if there is any one that is 90 degrees. Once you find any 90 degrees, then you use the Pythagoras Theorem to find the sides. So if we have something like this, we have C here, we have 4 here, and we have 12 here. This is still a right-angled triangle because there is angle 90 degrees inside it. Now for us to find C, we use Pythagoras Theorem again. So this side facing facing the angle 90 degrees is the hypotenuse, which is the 12. So we have that h squared is equal to a squared plus b squared, or anything plus c squared. This is just the general formula. So h is our hypotenuse, a is the first adjacent, and b is the second adjacent. So let's have 12 squared is equal to, let's assume that the first adjacent is 4, is this 4. So we have 4 squared, and the second adjacent is this c squared. Now we are now going to have that 12 squared is 144 is equal to 4 squared is 16 plus c squared. And so here now we collect like terms. The numbers should stand alone and alphabet should stand on its own. So we have 144 minus 16. This is plus here. It is coming to this side. It becomes minus. Minus 16 is equal to c squared. Now we have this 144 minus 16 is equal to 128. 128 is equal to c squared. That is the same thing as saying that c squared is equal to 128. So no matter the side that you put the c squared, it is still the same. Now to remove this square here, we move it to this side, and if it is coming to this side, it becomes a square root. So c is equal to square root of 128. Square root of 128, we check if we can see perfect square inside 128, and 128 is actually, we can divide it by 4 to get 32. So this is equal to root 32 times 4. Root 32 times 4. Now we have that c is equal to root 32, we just separate two of them, times root 4. We also check again if you can see perfect square inside 32. 32 is 16 times 2, and 16 is another perfect square. So we have that c is equal to root 32 is 16 times 2, now times by root 4. So we now have that c is equal to root, separate everything, root 16 times by root 2 times by root 4. Now what we are now going to have is that c is equal to root 16 is 4. 4 times root 2 times root 4 here is 2 times 2. So c is equal to, we now write the ones that are whole number first before we write the one with square roots. So we have 4, now bring this one, times 2 times root 2. Now this means that c is equal to 4 times 2 is 8. 8 times root 2. We just remove this multiplication sign and put everything together. So it becomes 8 root 2. So this is the answer. Now, there's another way they can also draw the triangle for us. They can draw the triangle this way.